Inverse matrices. This is, it's overall fairly easy. You guys are going to be scared a little bit because there is fractions in it. But the fractions that you work with are at the very end, and that's it. Like, you're literally multiplying it by 1 over a number, and your fraction, the only thing you'll have to really work with a fraction is simplifying it, like reducing, and that's it. Alright, so, let's go definitions. First up, identity matrix. This is a matrix that, when multiplied by another matrix, equals the same matrix. Take out the matrix word and put normal numbers or no words in there, and I'll tell you what it is. It's a number that, when multiplied by another number, equals that same number. Okay? So, Booker, give me a number.
1.
Ooh, do something else besides 1.
2.
2. What's 2 times 1? 2. It's a number that, when multiplied by another number, gives you that same number. 2 times 1 gives you 2. That's what it's talking about. 1 is an identity because it gives you whatever you multiply by. An identity matrix acts like 1 in the matrices world. And it looks like this. 1, 0, 0, 1 for a 2 by 2. For a 3 by 3, which you'll never see besides right now, it looks like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? That's an identity matrix. A square matrix is a matrix with the same number of rows and columns. Hence, it will look like a square. Okay? That's why it's called the square matrix. Make sense? Pretty easy. Our main focus today is going to be on this word here, inverse. All right, inverses. 2 matrices that have the identity matrix as their product must work both ways. All right, so inverses are 2 matrices that have the identity, that would be 1, 0, 0, 1, as their product. Must work both ways. That's good and dandy for you guys, but what you guys are basically going to do today is you're going to be given a matrix, and there's a process that you can use to find its inverse. That's the main thing we're going to do. You're going to be given one matrix, and there's a process you're going to use, and we're going to find its inverse. That process is very, very simple. Okay. All right, now, this slide here tells you how to do an inverse. You need this nice little box right here. Okay. That's how you do the inverse of a 2 by 2 matrix. That's all we're going to do also, okay? We're not going to do inverses of a 3 by 3 or anything like that. Nothing crazy. All right, I don't even know how you would, besides using a calculator. So, the inverse of a 2 by 2 matrix. So you're going to be given the 2 by 2 little square matrices. They look like this, okay? Your standard 4 elements, A, B, C, D. Nothing new there. All right? To do this, you're going to take 1 and put it over top the operations of AD minus BC from your original matrix. AD minus BC. What is that? Anybody know? Familiar?
Is it 1, 0, 1?
Nope. Nope. You just did it. Twice.
No.
Actually, you did it 3 times. You did it twice for 2 by 2.
That's the
Which was called a?
yeah, determinant.
Thank you. Determinant. Good. You find the determinant of the original. Okay? You find the determinant of the original. See that? AD minus BC. Then, you do some changing to your matrix. Okay? You change the matrix from A, B, C, D to D, negative B, negative C, A. Okay? From A, B, C, D to D, negative B, negative C, A. So basically what you do is these 2 elements, they flip. These 2 elements, you change the sign. See that? That's all you do. Okay? and then you multiply through. Alrighty. Now, honestly, I think the box that's pretty good to have wrote down for a reference. I think doing it make a lot more sense. Okay, everybody good? Everybody ready? All right, here we go. First one. So we're going to find the inverse of this matrix. The matrix is a 2 by 2. It's got elements of 7, -5, 2, -1. Your first step, find the inverse of that matrix. Or not the inverse, sorry, the determinant. Okay? Find the determinant of this matrix. Okay, so we're going to take A and D, which are those two. Let me do colors here. Hold on. 7 times -1 minus BC. -5 times 2. Okay, 7 times -1 gives you -7, minus -5 times 2 gives you -10, -7 plus 10 gives you 3. Okay. Here, I'll show you. Okay. So your determinant is 3. You figured that out first, all right? Now, this is where you use the formula that you just wrote down. Okay, so you go 1 over determinant times this matrix E. Okay?
Is it -1, 5, 2, -5, then -2, then 7?
Almost. You take these two elements, okay, this is where you do your switching around. You take the two elements circled in green, you flip their spots. -1, let me do colors. -1, 7.
You gotta make the 2 negative also, don't you? That's what I did.
Yeah. You take the two that are circled in white, right up here, you change their signs.
Oh, it'll be 5 and positive.
So 5 goes positive, 2 goes negative. Okay, does everybody see that? Okay. You change the spots of the green ones. You change the spot of the white ones. Or sorry, I screwed that up. You change the spots of the green ones, change the signs on the white ones. There could be, yeah. And you, same thing. If they're both, if these are both, yeah. If these are both positive, make them both negative. If these are both negative, make them both positive. Doesn't matter. One of each, do one of each. Doesn't matter. Okay? Last step. Multiply all 4 of these numbers by 1/3. Okay? Which means you're going to have fractions. Yes, it does. But realize something here, people. This numerator will always be 1. Always. Okay? So all you literally have to do is go -1/3, 5/3, -2/3, 7/3. Put all of these in the numerator, put 3 in the denominator. That's your answer. That's it. Now, the only catch to that, and this it doesn't show up on this one and won't show up on the next one, you might have to reduce in here. Okay? So if you get like so say you got 6/3 or 9/3, something like that, you'd have to reduce that. But that's the only real catch.
So we have to find the determinant for anything always.
Ew. -19. Right? Okay. That's ugly. You know what, though? That's actually all right. Really doesn't matter, does it? Okay. So I made it negative on top. Everybody okay with that? Instead of putting it in the denominator. All right. And then you do your switch. Okay. So we take the first two, just like you do your determinants. I would do it in that same order. Okay. You do those two first, and you switch their spots. So -4, +3, and then you take the other two. You change their signs. So -7, -1. Okay. And then multiply them all by -1/19. So -1/19 times -4 gives you. Anyone? Anyone? Say it one more time, book.
Positive 4.
Good job. +4 over 19. Because negative times negative. Okay. Do -1/19 times -7. You get 7/19. 1/19. And then -3/19. Just like that. Okay. All right, for B. B equals -1, 1, -1, 1. So find its determinant. We go -1 times 1 minus 1 times -1. Turns into -1 minus -1. What is -1 minus -1?
Oh, you said it's 0.
0!
I thought you talking about the -1.
No. I'm talking about right here. I'm already down here. Keep up.
Yeah.
-1 minus -1.
Yeah. No.
That's 0.
No.
Okay? So that's 0. We put that under 1. And then we put what? Burke.
I got a question. Why do we have to put? Why do we have to make it a fraction?
That's the way the formula works.
Everything. Why can't you just put the 19, like the -19, just like multiply that?
So what do we write next? Right here.
Oh, one. It's just zeros, ain't it? -1 goes in the D spot, and 1 goes in the A spot. And then you look to multiply the 0. Multiply the, oh, wait, that's 0? Oh, undefined. I thought it was 9.
Thank you. Undefined. Okay? If you end with a determinant of 0, it's undefined. All right? Every time. All right? If it's a determinant of 0, you got undefined, and that's what you put. Okay?